Hello students and friends, most welcome to Dr. Acharya Academy. Today I will discuss on the kinetic energy and molecular speed. This topic has been taken from the unit number 5 of the CBSECH Chemistry class 11 syllabus. Today's class number is 104. In this class, we talk about the speed of the molecules and what will be its energy distribution and what will be the speed of the molecules of gas, average speed, root mean square speed, etc. So molecules of gas, they are always in continuous motion and they hit to each other and they strike the walls of the container also. And this is the reason for the change of this molecule speed and redistribution of energy of these molecules. So the speed of the gas and energies of all the molecules at any instance are not the same. So we will obtain the average value of speeds from this type of continuous motions of the molecules of gas. So this is one average calculation. If you consider the n number of molecules in a sample, then they have the speed, individual speed u1, u2 and up to un. Then as per the average calculation, it will be the UAV, capital U subscript AB. This denotes the average speed of molecules. It will be the summation of the individual speeds divided by the total number of molecules N. So Maxwell and Boltzmann, they showed the actual distribution of the molecular speed, which depends on temperature and molecular mass of a gas. So Maxwell derived a formula on the basis of this concept of the distribution of molecular speed, which depends on the temperature and molecular mass of a gas. So right side figure is there. You can see the two curves is there in respect of T1 and T2 temperature. When T1 is constant, then curve will be little bit up and sharply it is going down. Horizontal, this x-axis denotes the speed and y-axis denotes the number of molecules. And for the curve at the temperature T2, its height will remain lower. But to remember that the temperature T2 in this case is greater than the T1. So this curve is called the Maxwell distribution of speed. So now we see what will be the observation from this curve. You can see the very high and low speed, what will happen? You consider any one curve. Very high speed is this point, then y is almost 0. That means number of molecule is very less. One thing you have to remember, it did not touch the x-axis, just above it is going. That means the number of molecules having highest speed is very low, and similarly at low speed, lowest speed, it is close to the y is equal to 0. That means number of molecules will be very small. So the maximum, this is the maximum point. If you consider this curve, then the maximum in the curve represents here whatever the speed is there. That means the speed having the maximum number of molecules, it is called the most probable speed. So in this point, what are the speed of the molecules? It is called the most probable speed, which is denoted by the UMP. U subscript MP. MP means most probable. And this point, whatever the most probable speed, it is very much close to the average speed of the molecules, because in this point, the maximum number of molecules contain almost the same speed, which is called the most probable speed. And from the average speed, that is the averaging of the individual speed of the molecules, so both will be close in this Maxwell distribution curve. And on increasing the temperature, T2 is greater than T1. So number of the molecules, though it is less in the top, but here the speed is more. If you consider the x-axis, then you can see that for the T2 temperature, it is speed is more than this speed which is at less temperature. So with the temperature increase, the most probable, because this point regarding to the most probable speed, so it increased. And others observation, you can see whatever I discussed, that for temperature in increasing order, this speed distribution is broadened. You can see this, and broadening of the curve shows that the number of molecules moving at higher speed increase, because higher speed, this is the higher speed, this point is above than the T1 point. That means if right side also this point you consider, so the molecules at this point have higher speed than the molecules at T1 temperature. So now at the same temperature, so when temperature is remains same, then another variation, that means the mass, we need to consider, which is the part of the Maxwell distribution law also. So generally, when the heavier mass molecules, it has slower speed than the lighter gas molecules. So example, at the same temperature, nitrogen molecule, we know it is a lighter molecules than the chlorine molecules. So nitrogen molecules at the same temperature will move faster than the chlorine molecules. So at any given temperature, nitrogen molecules have higher value of most probable speed than the chlorine molecules. We have to remember, though, at a particular temperature, the individual speed of molecules keeps changing, but the distribution of speed remains same. Distribution will be like this only at the same temperature, but distribution of the molecules speed will remain same. This curve pattern will not change. Now we'll consider the kinetic energy. So kinetic energy depends on the speed. A general expression of the kinetic energy is 1/2 mu square. And so this u square will know in the previous, here we're considering this is will come from the movement of a gas particle in a straight line, and now we'll introduce another term which is the mean of square of the speed, which will better represent the speed of molecules, which is denoted by u square bar for all molecules, and this will represent u square bar, which is the mean of square of speed. It is equal to the summation of the square of the individual speed divided by the number of molecules. So in this way, we can calculate the value of mean square of speed. So the mean square speed is the direct measure of the average kinetic energy of gas molecules. So to remember here that when we will calculate the average kinetic energy of gas molecules, we have to use the value of mean square speed. And if we take the square root of the mean square of speed, which is another term, URMS, U subscript root mean square, RMS, all in small letter, then we'll get different value from the most probable speed and average speed. So this speed is called the root mean square speed, and mathematically it will denoted by this. That means the URMS is equal to square root of mean square speed. That's why it is called the root of mean square speed. So now the root mean square speed, average speed, and the most probable speed, what is the relation between them? Root mean square speed, this is the highest, and the speed at most probable value, it is the lowest, and the average speed is in between. We can count the ratios of these three speeds, and this ratio experimentally is found that it is the most probable speed, average speed, and root mean square speed. This ratio is 1 to 1.128 to 1.224. So I hope that you understand different type of molecular speed and their calculation, how to calculate, and kinetic energy of the molecules, especially the Maxwell distribution curves, and what is the characteristics of this molecular distribution curve. Thank you so much for watching this class.